Today we're going to talk about relations and functions, what they are and what the difference between the two are. But before we do that, I want to do a little extra side one with you. I want to do dimensional analysis. And this is just a way to convert from one thing to another. So let me just show you this very quickly. This states 72 miles per 1 hour. Now, if I want to find out what that is in, let's say, feet per second, then what I need to do is I need to do a series of conversions. And what I'm going to do is I'm going to put little conversion boxes here. And conversion boxes are where you put your conversion rules. So I'm going to put a couple of those, and then I'm going to show you how to decide what goes in there. All right, let's talk about miles and changing it into feet. Do you know any conversions or any kind of connections between miles and feet? I'm hoping you know that 5,280 feet is equal to 1 mile. Those are exactly the same thing. So what I'm going to do is I'm going to take these two pieces and I'm going to write it down as a fraction. I just have to decide which part I want to put on top and which part I want to put on bottom. Since miles is on the top here, then I know for this conversion I want to put miles on the bottom and then feet is going to go on the top. So now I just fill it in. 5,280 feet is 1 mile. Now what happens there is that the word mile cancels out with the word mile and I'm left with just feet on the top. So I'm finished with that part. Okay? Now I have to convert hours into seconds. Well, I don't want to do that all in one step. I want to think to myself, okay, you know what? I know that 60 minutes is equal to 1 hour. So I'm going to use that conversion. Since the word hours is on the bottom, I'm going to put hours on the top. So 1 hour is the same thing as 60 minutes. And at this point, the word hour cancels with the word hour. So now, at this point, I'm at feet per minute. So now I need to think of another one. Okay, well, you know what else I know? I know that 60 seconds is equal to 1 minute. Since minutes is on the bottom, I'm going to put minutes on the top. So 1 minute, 60 seconds. And now the word minutes cancels out with minutes, and I'm left with feet, the word feet on the top, and seconds on the bottom. So now I'm just going to work this out. So now I'm just going to multiply straight across, and that's going to give me 380,160 feet in 3,600 seconds, which reduces to approximately 105.6 feet per second. This is a great tool for science. Okay, let's go on. Here are some words that you need to know: relation, domain, range, and function. Please make sure that you pick the meanings of those up as we go along. The domain is the x values. It's the first coordinate. We call them the domain. A lot of times we call them the input, but domain, when they ask you for the domain, they're talking about the x values in a relation. The range is the y values. So if I were to give you these ordered pairs here, I would tell you that the domain is 1, 2, 3, and 4, and the range is 5, 3, 2, and 1. I'm giving you ordered pairs. I'm giving you the ordered pair 1, 5, 2, 3, 3, 2, and 4, 1. Okay? Here I'm asking you for the domain and the range, but this time it is for a continuous graph. Now that's going to be different because I cannot go in here and specifically pick out the individual x values. What I can tell you, however, is that this is the smallest x value and this is the largest x value. So I can tell you that my x values are somewhere between 1 and 5. So I've set up a compound inequality here, basically saying these are my x values. My y values are going to be here. This is my smallest y value right here at 3, and my largest y value at 4. So my y values, which is my range, are between 3 and 4. Okay? I can also give you the domain and the range from mapping. Now, this was from a graph, This is an ordered pair. There's your domain. There's your range. Okay? Here's from mapping. Remember, in mapping, these are your x values. These are your y values. And the arrows tell you what matches with what. So my domain is 6, 5, 2, and 1. My range is -4, -1, and 0. And if I were to actually match these up and make ordered pair, it would be 6, -1, 5, 0, 2, -4, and 1, 0. These two share the same y value, which is actually fine. Okay? So here I'm asking you for the domain and range. So from a chart, this is your domain. So you just list those values. This is your range. And you'll notice that you do not have to list the duplicates. Your range means your choices for your y values are 1 and 4. So you only have to put them down like that. Now, a relation is where two variables are somehow or another linked together or connected, have some kind of relationship with each other. A function is a special kind of relationship. It's like having a best friend, okay? And the definition here says that each domain value is paired with exactly one range value. What are some other ways to say that? Every x has only one y value. There's no choices. It's not when I pick x, I can say, well, the y value could be this or it could be that. Only one choice. Okay? Here, I'm going to ask you to give me the domain and the range, and then I'm going to ask you to tell me whether it's a function or not. So, my domain is going to be what? Again, you're probably going to want to pause the video so that you can do this and then check your answers. My domain is going to be 3, 5, and 4. And again, I only write the 3 once, even though it's twice. And my range is -2, -1, 0, and 1. And this one's not a function. Now, the reason this one is not a function is because for the value for x of 3, there was actually two different y values. So 3 gave me -2 one time, and 3 gave me 1 the other time. That means it is not a function. You can also tell if something's a function from mapping. All right, my domain here is going to be -4, 8, 4, and 5, and my range is going to be 2 and 1. I can see that there are no repeating x values, but also I can see that there are not two arrows coming from the same x value. So for instance, if there was an arrow going here also, then that would not be a function because that's telling me that -8 went with the 2 and with the 1. But since there's not more than one arrow coming from any x value, then this one is a function. Okay, let me scroll down here so you can see that. All right. All right, this one's a little bit more difficult because this is a continuous graph. So I'm going to look at that and I'm going to say, okay, what are the x values? Well, the smallest x value I can see here is what? That's -2, 3, 4, -5, which is out here. And the largest x value that it looks like they use is +3. So my domain is going to be between -5 and +3. My range, my smallest y value, y remember is up and down, so it looks like it's here at -2, and the largest y value looks like it's here at 1. So my range is -2 is less than or equal to y, which is less than or equal to 1. Now, how do you tell if something is a function based on a graph? You use what's called the vertical line test. So here's my vertical line right here. And what I'm going to do is I'm going to take the vertical line and I'm going to scan it across my graph. And as long as my vertical line doesn't touch the graph in more than one place at any given time, then it's a function. So as I come across here, problem right here. Do y'all see this? It's touching it. Let's put a dot there. It's touching it right here, and it's touching it right here. Okay? Let me move my line out of the way. Can you see that for the x value of 2, there are two possible y values that go with it? So this is not a function. It does not pass the vertical line test. Okay? It has to pass the vertical line test. Okay? All right. So What I want you to do here is I want you to give me the domain and the range, and then I want you to tell me whether the relationship is a function or not. Again, pause the video to do this. All right. For this one, the domain, -6, -4, 1, and 8. The range, 1, 2, and 9. It is a function. There are no repeating x values. No duplicate numbers in the domain. Okay, for this one, your domain, oops, got to get it all. Your domain is 2, 3, and 4. Your range is -5, -4, and 3. This one is not a function because of this guy right here. Do you see the 2 arrows going out there? That means that 2 has, the number 2 for x has 2 possible y values. That makes it not a function. All right, how can I tell from graphs? Remember, it's the vertical line test. So here's my vertical line. Let's take it over to this one. Holler if you see it touching the graph in more than one place at any given time. Nope, that's a function. All right, let's try this one. Holler! Right there, see it? Do you see that it's touching it? Here, here, and here. That makes it not a function. Okay, let's try the next one. Oh, we're good. Okay? No repeating x values, no double arrows from an x value, passes the vertical line test. That's how you can tell that it is a function. Now, how functions work very quickly, I'm going to make like what I will call a function machine. You have something that goes into the machine and it spits out an answer. Now, what goes in are our x values. What comes out are our y values. Other words we use. What goes in is our domain. What comes out is our range. See, these are just all words that mean the same thing. Apply it to science. What goes in is your independent variable, the value for your independent variable. Something happens to it inside here, and out comes your dependent variable value. Okay? And then what goes in the middle is your rule. So, for instance, if I say y, oh, I didn't mean for that to look like that. Let's get rid of that. Okay, let's use a different pen here. So if I put y is equal to 2x plus 4, then what happens inside here is I take whatever value for x that you put in, I multiply it by 2, and I add a 4. Okay? So let's pick a value, any value we want to. Let's pick a 3 for x. So here's what happens. The 3 goes into the function machine. I multiply 2 times 3, which is 6, plus 4. So what happens is that 3 transforms inside there, and out comes a 10. So the 10 comes out. So, all right, let's just repeat that so that you can see that. All right, the 3 went in, something happened to it inside here, and the 10 came out. The 3 is my input, so something went in, my input, my x, my domain, my independent variable. The function did something to it, and my output, or my y, my range, my dependent value is going to be a 10. And we just repeat that over and over. That's it.